Good morning. So we're going to continue chapter 5 here. Now we're going to talk about solving quadratic equations, what that actually means, and we'll be doing that by factoring here. So this is section 5.2. Now solving quadratics by factoring. Zero product property. So if we take the zero product property, if the product of two factors is 0, remember, product, that means multiplication. If the product of two factors is 0, then one or both of the factors must be 0. And that makes sense. If I take the product, let's say I take A times B. If that equals 0, the only possible way for A times B to equal 0 is if A equals 0, or B equals 0, or both A and B equals 0. Now here, let's take a look. That tells us that if one of our factors is 0, then the product together will be 0. So x plus 4 times 0, well, anything times 0 equals 0. And that means that 0 times anything also equals 0. And if 0 times 0 equals 0, if 0 times 0, then we're going to have that equal 0 as well. Now, if we are solving a quadratic equation, so sometimes a problem, your instructions will simply be solve. It'll say solve, and then it'll give you an equation. So if we're solving a quadratic equations, it means finding the values of x that make the equation true. Okay, it means finding the values of x that will make your left side equal your right side. So the solutions to the quadratic equation are known as the x-intercepts, also known as the roots or the zeros. Okay, it's up to you to recognize each of these words in a given problem. Some quadratic equations, not all, but some quadratic equations can be solved by factoring and using the zero product property. Now, if then we are solving a quadratic equation, before we factor, we have to make sure that one of the sides of this equation equals 0. After we have it equal 0, then we're going to factor the left side of the equation. Then we'll set each factor equal to 0 and solve for x in order to find out the solutions. So first we'll start off with example 1a. And we see here, we need to make sure that the equation is set equal to 0. Do we have that? Yes. One side equals 0 right now. So that's all finished for us. Then we need to factor the left side of this equation. So we're using our factoring skills that we learned already. In this case, we need to multiply to 6. We need to add to -5. Okay, so if we're multiplying to 6, that means we're working with we can list off the factors of 6. That's 1 and 6. That's 2 and 3. And then the negative factors as well. So that's -1, -6, -2, -3. And let's add these up. If we add up across the row here, then 1 plus 6 equals 7. 2 plus 3 equals 5. -1 plus -6 equals -7. -2 plus -3 equals -5. That's the one we're looking for. Right? They add up to -5. If that's the case, then we can factor this down here as x minus 3, x minus 2 equals 0. Okay, if x minus 3 times x minus 2 equals 0, my left side is factored. That means that one or both of my factors must equal 0. So we'll start off and we'll set x minus 3 equal to 0. We can rearrange this. We add 3 to both sides to find that x equals 3. So this is one solution. Okay, next we'll try setting the other factor. Set x minus 2 equal to 0, and we can rearrange this. We add 2 to both sides, leaving us with x equals 2, and this is the other solution. Now, sometimes we will have one solution. Sometimes we'll have two solutions. Other times we'll actually have 0 solutions. You'll see what those look like in future lessons. But right now, we're going to work from here. And that means, therefore, x equals 2 or x equals 3. Those are our solutions. So now we'll go on ahead and try B. If you think you're understanding it right now, you can pause the video, try it out on your own, and see how it works. But either way, we're going to go through it here. So we're checking. So before we factor, we have to make sure one side equals 0. Right now, is that true? No, my right side equals negative 15. So I need to rearrange this equation so that my right side equals 0. That means I'm adding 15 to both sides, leaving me with 0 on the right-hand side. That's 2x squared minus 11x plus 15 on the left-hand side. And this we recognize as a complex trinomial. The first one was a simple trinomial. This one's a complex trinomial. A complex trinomial, you know how to factor by decomposition. So if we're factoring by decomposition, then we need to multiply to a times b, right? We need to multiply here to 30. And we need to add to negative 11. Okay, so if I'm multiplying to 30, I can list off the factors. That's 1 and 30. That's 2 and 15. That's 5 and, 3 and 10 here. 5 and 6. Then I can list off the negative factors. That's negative 1, negative 30, negative 2, negative 15, negative 3, negative 10, negative 5, negative 6. And I'm looking for the ones that add up to negative 11. If I'm adding them up across the rows here, 1 plus 30 equals 31. 2 plus 15 equals 17. 3 plus 10 equals 13. 5 plus 6 equals 11. Negative 1 plus negative 30 equals negative 31. Negative 2 plus negative 15 equals negative 17. Negative 3 plus negative 10 equals negative 13. We know the drill here. Negative 11 as my last one here. That's the one I'm looking for. It adds up to negative 11. So the two numbers I'm working with, how I'm going to decompose this left-hand side, that's 2x squared minus 5x plus, minus 6x plus 15. And then I'm going to group this into the first two and the second two. Let's see here. I'm grouping this, I'll just use a different color. First two here and the second two. Right, so I can rewrite this here, and I will. That's 2x squared minus 5x. And here I'll make that a plus sign, plus negative 6x plus 15 equals 0 still. And then I'm going to take the greatest common factor out of each pair of terms here. So my first pair of terms, my greatest common factor is x. So that's x, leaving me with 2x minus 5. My second set of brackets, I'll take the greatest common factor out, and that's going to be, I'll make my, my first term positive as well. So we'll take out a negative 3. Minus 3 times 2x minus 5. Okay, and I recognize that 2x minus 5, that shows up in the first part and the second part. So it's like I'm factoring out the 2x minus 5, right, from the entire thing. So if I factor that out, that leaves me with 2x minus 5 here and x minus 3. So there I am. I've factored my complex trinomial. Now that I've factored my complex trinomial, I need to, I factored it. Now I need to set each factor equal to 0 and solve for x. So if I'm doing that, let's go over here. I know you may have run out of space there. So we'll set 2x minus 5 equal to 0. We'll rearrange this. We add 5 to either side. 5 equals 2x. And then I divide both sides by 2, leaving me with x equals 5 over 2. That's my first solution. Then I'm also going to set x minus 3 equal to 0. That tells me that x equals 3 after I add 3 to both sides. Therefore, x equals 5 over 2, or x equals 3. If you're solving this, you need to find both solutions in order to get full marks for questions like this. Okay, now let's keep going. We're using these factoring skills that we learned in the last unit, remember. So here, if I double check, my right-hand side already equals 0. That's my first step. That's all I need. Once it's there, that means I'm factoring. And I notice here, I have only 2 terms. I don't have any C term, right? So if I'm looking at this in standard form, it would be like C equals 0. And if that's the case, I recognize I should be able to common factor everything over here. And in fact, I can. My greatest common factor is 5n, leaving me with n minus 5 here, equals 0. Then again, I'm setting each factor equal to 0. So first off, we'll set 5n equals to 0. That means that n equals 0 if I divide both sides by 5. And I can also set n minus 5 equal to 0, and that tells me if I add 5 to both sides, n equals 5. So therefore, n equals 0 or n equals 5. Fantastic. So we're going to take this example here. We take a look right away. We recognize our right-hand side does not equal 0. We need one of our sides to equal 0. So let's move that term over to the left side, if you will. So we're adding 25 over 4 to both sides, leaving us with 0 on the right-hand side and x squared plus 5x plus 25 over 4 on the left-hand side. And from there, hopefully we do recognize that as a perfect square. That is x plus 5 over 2 squared equals 0. Fantastic. If we have here, this really is one factor happening twice, right? X plus 5 over 2, that's the same factor happening twice. So we set that equal to 0. Set x plus 5 over 2 equal to 0. And then we can rearrange this. So we subtract 5 over 2 from either side. We find that x equals negative 5 over 2. That's my lone solution. That's my only solution here. Therefore, x equals negative 5 over 2. Now, as a double check, what I do encourage you to do as a bit of practice work here, substitute each of these roots that we've just found, right? So in 1a, we found x equals 2 or x equals 3. In 1b, we found x equals 5 over 2 or x equals 3. In 1c, we found n equals 0 or n equals 5. And then example 1d, we found x equals negative 5 over 2. So I would like you to substitute each of those roots individually into their original equations. So those are the equations that we were given. And then double check your left side and right side. Double check to see that both sides are equal. Now we will continue on, so let's take a look at an application here. So a ball's thrown from a cliff, its height in meters above sea level after t seconds. So this time our So this time our independent variable is time. Our dependent variable is the height of this ball in meters. And this can be modeled by the equation h equals negative 5t squared plus 21t plus 120. They're asking us how long will it take the ball to fall 20 meters below its initial height. Okay, so we need to take a look here, and we can find, first of all, its initial height. We know we're going to need that, so we'll find the initial height. And we know how to do that. If we're finding the initial height, we can substitute t equals 0 into the original equation. Or if you are familiar with your standard form, you can take a look at this and say standard form tells us the initial value right off the start. That's the c value. So our initial height equals 120. Our units are meters. Now they're asking us how long will it take the ball to fall 20 meters below its initial height. So that means they're asking us how long will it take for the ball to reach a height of, we'll make that our goal height 100 meters, right? That's 120 meters minus 20 meters. So if our goal height is 100 meters and we know we have this model up here, then we can substitute this goal height, sub h equals 100 meters, into, we'll call this equation 1 up here, into equation 1. So then we're working with 100 meters equals negative 5t squared plus 21t plus 120. Again, as we did before, we need to rearrange this equation so that one side of this equation equals 0. Well, the easiest way to do that is to move everything from the left side to the right side because there's only one term here on the left side. So if we subtract 100 from each side, that'll leave us with 0 here on the left. And on the right, negative 5t squared plus 21t plus 120 minus 100. Nice and easy. That leaves us with negative 5t squared plus 21t plus 20. Now here, if we're going to factor something like this, this is a complex trinomial. If it's a complex trinomial, then we need to multiply here to negative 100. We need to add to 21. So we'll try that out here for multiplying to negative 100. That is 1 and negative 100. 2, negative 50, 3, doesn't work, whoops, 4, negative 25. And already I'm seeing it. We don't necessarily need to write out more than this if we see our solution here. So that's negative 99 if we're adding across here. Again, we add across, that's negative 48. Adding across, negative 21. Okay, so if I know negative 21 is there, sorry, we will keep going a little bit. Then I could try negative 4 and 25 to bring that to a positive 21. That's our goal. If you like that process, that shortcut, you can use that. If you don't see that shortcut, you can just go through this and factor it like a regular simple trinomial that you're used to factoring. And we're going to decompose it. So we have negative 5t squared minus 4t plus 25t plus 20. Plus 20. Good stuff. Now that it's decomposed, we're going to find a common factor from the first two terms, right? The first two terms and the second two terms. That's how we're breaking this apart. Here we can factor negative t. So negative t leaves us with 5t plus 1. Plus 4. 5t plus 4. And then we can factor out a common factor of 5. So plus 5. Leaving us with 5t plus 4. Fantastic. We do recognize this 5t plus 4 on the left and the right, so we'll factor that out. That's 5t plus 4, leaving us with 5 minus t, or negative t plus 5. Fantastic. So it's fully factored. We're looking for solutions here, right? So if we're trying to find these solutions, we'll take these two factors and we'll set each of them equal to 0. So first, we'll set 5t plus 4 equal to 0. And we'll rearrange this, trying to isolate for t. So we'll subtract 4 from either side. 5t equals negative 4t. Then we divide both sides by 5t equals negative 4 over 5. Okay, now the problem with this solution here, if we look at the context of the problem, then a ball is thrown from the cliff. What time is the ball thrown from the cliff? Well, at t equals 0. That's when we start this model. Now, if this model begins at t equals 0, then any value for t that is less than 0 is going to be inadmissible. So right here, since we see that t is less than 0, it's a negative value. If it's a negative value, it's less than 0. Inadmissible. And that means we cannot use this as one of our solutions because negative time does not make sense. It does not exist. So then we'll double check. We'll go into, we'll go from here. We'll check our other factor. So we'll set negative t plus 5 equal to 0. We'll add t to either side, leaving us with t equals 5. This makes sense. This is a positive t value. Therefore, this only has one solution. Therefore, t And let's take it back to the context of the problem for this conclusion. How long will it take for the ball to fall 20 meters below its initial height? It will take 5 seconds to fall to 100 meters. Again, so here we came up with two solutions, right? We have two distinct routes, two separate y-intercepts here, or t-intercepts, if you will. And but we took the context of the problem to take a look at this and say, hang on, only one of these is going to be useful to us. That's going to be the one we use for our conclusion. And we'll jump forward into one last problem here, one last application. Oops, apparently there is a third after. Number 2. So a rectangle has dimensions 3x plus 1 and 2x minus 5. We don't know what x is. Its area is 1,150 centimeters squared. We have to find the exact dimensions of the rectangle. So we need to find the solutions to this, right? Our area, we know, equals length times width. Well, here we have our length, we have our width. So that means that our area, and really if we're writing area, we should use a capital A. That means that our area equals 3x plus 1 times 2x minus 5. Now, the other thing we know is we know our area. Our area equals 1,150 centimeters squared. So 1150 on the left-hand side, and then all of a sudden, this is a quadratic problem that we need to solve. If we're solving this, we need to move everything over to the right-hand side. So let's do that here. We subtract 1,150 from both sides, leaving us with 0 on the left. 3x plus 1 times 2x minus 5. All minus 1,150. And that's great, but this is not of any form that we know how to factor, right? We cannot factor something like this. We don't know how. So if we're trying to figure out how to factor something like this, we need to set it up like we're used to. Like we're used to means something that's like standard form. If we're looking for standard form here, there are no brackets. There are no brackets. We need to use our FOIL to take these two binomials that are being multiplied together. So these two pair of brackets being multiplied together, and we need to use that FOIL to expand them. So that brings us to 6x squared minus 15x plus 2x minus 5 minus 1,150. And we can take that even further. That's 6x squared minus 13x minus 1,155. And as a bit of a challenge problem for you, I'd like you to try and factor something like this. If you can, that's fantastic. You can use your calculator when you're practicing something like that because the numbers we're using get pretty large pretty quickly. But it does factor into something that looks like 6x plus 77, x minus 15. And from here, we can interpret our solutions, right? So we set each factor equal to 0. So x minus 15 equals 0. We isolate for x and we find x equals 15. Or we set 6x plus 77 equal to 0. We isolate for x. That is, we subtract 77 from either side. 6x equals negative 77. Looks like we need a tiny bit more space here, and that's all right. And then we divide each side by 6, leaving us with x equals negative 77 divided by 6. Well, we need to ask ourselves, we need to bring it back to the context of the problem and interpret each of these. So first, we're looking at what is x? Well, x is it's a piece of the dimensions of the rectangle, right? And in both cases, with both dimensions, then x is used in a positive fashion. So it wouldn't really make sense if x is a negative number, because if x is a negative number, that would give us a negative length for both of our sides here, and we can't have a negative length. So since it's negative over here, since this solution is negative within the context of this problem, this is inadmissible. Inadmissible. The other one gives us x equals 15. Well, that's fantastic. Working with x equals 15, we can find the two dimensions. The first dimension would be 3x. Really, we should sub x equals 15 into 3x plus 1. So 3x plus 1 would become 3 times 15 plus 1. If we simplify that, we find it equals 46. And on the other side, that's 2x minus 5, bringing us to 2 times 15 minus 5. That's 30 minus 5. That equals 25. So therefore, the dimensions are 46. And what are the units here? Centimeters times 25 centimeters. Fantastic. And lastly, let's look at creating a quadratic equation with the following information. So we're writing a quadratic equation in the form a times x squared plus bx plus c equals 0. That's in standard form with the following roots. Well, if it has these roots, then we can come up with some factors here, right? Because if it has the roots at x equals positive 3 here and at x equals 5, then we can come up with the factors by setting, by finding what, by finding a factor that would equal 0. So if I rearrange this equation on the left-hand side so that the right side equals 0, I would need to subtract 3 from both sides. So that's x minus 3. That's my first factor. My second factor, from here, I'm rearranging it so that my right side equals 0. And sorry, I need to give myself a little more space again here. So we subtract 5 from both sides. That's x minus 5 equals 0. That's my second factor. So since I have my two factors, I could write it in factored form. That is 0 equals x minus 3, x minus 5. But we don't want it in factored form here. We want to work with our equation. We want to put our equation into standard form. For putting it into standard form, we need to use our FOIL here. And that'll bring us x squared minus 8x. And really, let's do that separately. Minus 5x minus 3x plus 15. Then we collect our like terms. That is x squared minus 8x plus 15. There you are. This looks in standard form, which is what the question was asking for. And then we can perform a similar pattern over here. This time, though, we're working with fractions. So if we're working with fractions, let's try it out. That tells us that x equals 1/2 is a root, and x equals negative 3/4 is a root over here. So let's rearrange this first side. That is, I can multiply both sides by 2, so that's 2x equals 1, and then I can subtract 1 from each side, so 2x minus 1 equals 0. And on the other, working with our other root here, that's 4. We multiply both sides by 4, so 4x equals negative 3. And then adding 3 to both sides will bring me to 0 on the right-hand side. So 4x plus 3 equals 0. Fantastic. Here are my two factors. Let's split up our work here. Those are my two factors. So I can set it into factored form. Two x minus 1 times 4x plus 3 equals 0. And from here, we're working. And again, we apply our FOIL. So that is 8x squared plus 6x minus 4x minus 3 all equals 0. And then we can collect our like terms. So that is 8x squared plus 2x minus 3. There we are. It's in standard form as the question asked. So I'm hoping now you should be ready to handle the homework here. Try it out and see how it goes.